Hey, welcome. All right, let's get started again. Another homework assignment that I am going to be planning on doing for my students. Just going to kind of work on evaluating inverse trigonometric functions. So in this one, we're basically just going to kind of go through evaluating not only inverse trigonometric functions, but also the composition of those functions. So let me just go ahead and set up my chat here real quick and play along. Just wait till some people go ahead and get in that want to go ahead and follow or also have some things. Hi Mavenda, hi Orion, hello guys, welcome again. This is my second live stream going down in this format, so I'm excited to kind of keep on improving the format and keep on revising it. As of right now, I'm currently teaching, so the easiest thing for me to do is to go over the homework assignments that I've been signing in class. But obviously, as I evolve this process, there's going to be other things I'm going to want to add. So, hey, Jan. All right, let me just get this live chat to pop out, and therefore we'll be... There you go. Now it's a little bit easier for me to kind of go ahead and follow everything. And there's follow that. Make sure everything is going good on my end so I can go ahead and follow along with you guys. And I think we'll be all good. This one is going to, again, it's going to be kind of a note session. So right now I'm just kind of starting everything, in front in my dining room. And then we'll go over to Notability to go ahead and get started. So what we've previously been talking about in my class is working on the inverse trigonometric function. So when I'm kind of doing my instruction here, what I will be doing is, kind of going through some elements of it, but I'm not going to be teaching it from a very beginner set because that's obviously what I've been doing in class. And I did record a couple videos for you that will be coming up on YouTube recorded, but this is just really kind of in the element for me to kind of review some of the things. So it's not really introductory to the inverse trigonometric functions, but it would be, it is kind of like a little review. So if you've gone through the lesson before, or if you have a little bit of an idea, this would be like a good review kind of for you. So before I go ahead and get started here, I would like to kind of check in, kind of see if you have any initial questions. And then also I'd love to kind of hear where you guys are from and what math class you guys are currently taking, or if you're just hanging out and watching some math. So let me know where you guys live and what kind of math class you guys are taking. So Vishnu, hey, Juran, Jayan, hello. Ian, I have a question. Do you teach high school or university? Ian, I teach at high school. This is my 11th year teaching at high school, and I teach down in Jacksonville, Florida. Hi, Charlene. Good to see you again. I'd be ready. All right. Let's go ahead and get started. So what I'm going to work on is just a couple problems that we kind of started in with our class. And I will try to make sure that I'm utilizing some colors. And obviously, ladies and gentlemen, obviously, as I'm working through this, if you have some questions, let me know. I will try to, I will take a break kind of midway in here to make sure that I can kind of encapsulate any kind of questions. If you have questions from another class currently, like Algebra 1, Algebra 2, Calculus, Pre-Calculus, or whatever else, you can ask them at the end. I'll kind of see how much time I have after, and I'll be happy to answer any questions that I can. But the idea of at least this format right now is not to get directly into too many questions, but I do have some ideas as far as opening up so we can do a lot more kind of, open questions, have you guys submit questions, ask questions, and I can go and help you out. So, yeah, as far as the Algebra 1, I want to do some more stuff on Algebra 1. This is probably higher in the Algebra 1. I'm not sure if everything kind of changes with what's in the new curriculum and what's not, but I'm actually going to be in an Algebra 1 classroom tomorrow doing a little introductory teaching, but they're doing the quadratic formula. But I don't remember when I taught Algebra 1 getting into trigonometry. So this might be a little bit, but it's also a good review, especially if you're going to be going into geometry and, possibly pre-calculus. This is something that will be covered. Okay. I live in Mexico and I see ellipses. Awesome, Ian. All right, so let's go ahead and get started. So the first question that my students were working on was question number 5. Actually, hold on a second. Let me move this. over here. So therefore I can kind of see. Last time I had some problem with my problems kind of covering what I was teaching. So I want to make sure I keep on scrolling up. So I have a little window here for me to view that on. All right, so question number 5 was basically asking us to evaluate the sine of pi over 6. Now, actually what these first 3 problems were these were actually review problems. So, basically what I've been telling my students is when we're looking at evaluating the 6 trigonometric functions, the main important thing we want to make sure that we remember is the first quadrant of the unit circle. And I probably actually, you know what? I need to make a bigger one because I'm not as versed in this right now. So let's make this nice and big. So that's supposed to be a quarter circle. But when we're evaluating the unit circle, all right, and I've already done a lesson on where the unit circle comes from using these special right triangles. We're able to equate these lengths, the unit circle, all these lengths here, which can represent the hypotenuse of your triangle. Also, the radius of the circle are all going to be 1. So using the idea of special right triangles, we can see that, this point is going to be, comma 1/2, comma square root of 3 over 2. Coordinate point. This point is going to be square root of 2 over 2, comma square root of 2 over 2. And then this point is square root of 3 over 2, comma 1/2. Now, these other 2 points, which are important to also remember, is 1, comma 0. And this point over here, which is again going to be 0, comma 1. Now, I'm not sure if I can fit my angles in here. I'll try to do the best. But this first angle is 30 degrees, or pi over 6. The second angle is 45 degrees, which is the same thing as pi over 4. And again, these pi over 6 and the pi over 4 are the radian measure, which is another thing we talked about earlier in this chapter is, the differences between radians and degrees. And then this one is going to be pi over 3. I could just zoom in. That'd probably make my life a little bit easier. And then the last one, that angle is going to be pi over 2. So, all right. So what's important about this, though, is we have these triangles. And again, these are all based off of special right triangles. And so if we're writing for the sine of pi over 6, basically what they're asking us is, the same thing. Sine, if you remember from, previous thing, is opposite over hypotenuse, right? And so if we look at, creating this as an opposite over hypotenuse, the hypotenuse is 1. That's the basic understanding of the unit circle. So it's basically going to be the opposite, which is this length right here, which represents the y-coordinate. So that's why a lot of times they say, sine is the y-coordinate. It's not really, it's the y-coordinate, but it's the y-coordinate on the unit circle when the hypotenuse is equal to 1. So therefore, in this case, the sine of pi over 6 is just going to equal 1/2. Moving on to question number 7, which was what is the cosine of 2 pi over 3? So on 2 pi over 3, what we have to do now is kind of understand a little bit more about reference angles. So when we're looking down here and we're looking at, the reference angle, so the main important thing is for this first triangle or the first quadrant, we know that this angle is pi over 3. If we were to reflect this over here across the y-axis, then we know that these angles would be symmetric, right? So this measure would still be, again, pi over 3. Now, the only difference for these 2 coordinates, we know this coordinate is 1/2, comma, square root of 3 over 2. So therefore, this point, since it's in the second quadrant, is going to be -1/2, comma, square root of 3 over 2. All right, now, the main idea to kind of understand what this angle is, right, because that's basically what we're looking at is 2 pi over 3. We want to make sure we have that angle. So we know that halfway around a circle, I almost had it, is going to be pi. And if we're dealing with that angle in terms of thirds, that would be 3 pi over 3. So if we want to get, if we want to find 2 pi over 3, if we look at this, if this is 3 pi over 3, if we subtract this 1 pi over 3, then we're going to get the angle from here to here is going to be 1/3 2 pi over 3. So you can see how that creates, your 2 pi over 3. And then we want to look at the cosine, which again would represent the adjacent side. So if we kind of created like a right triangle here, the adjacent side over the hypotenuse, again, the hypotenuse is 1. The adjacent side is represented of the x-coordinate, which in this case is just going to equal -1/2. And the last one here, and then I'll go and take a break and kind of look at some questions, kind of see if I can help you guys out, is going to be question number 9. Number 9 is tangent of negative pi over 4. Okay, so just remember everything that we've been doing so far, or at least in this angle, you can see that I'm going counterclockwise, and that direction is the positive direction. So if I'm going to be heading in the other direction, clockwise, that is what we call the negative direction in standard form. In the exact same thing, this is a really bad 4, so let me fix that, see if I can. Let's zoom in here and try to fix that 4. Let's erase that. That's a really bad 4. Sorry about that. No, didn't want to do that. So let's redraw that. Doot. Still trying to get used to this, guys. So just give me a little bit, and I will. I'll be getting myself all good for this. But it is going to be something that's going to take a time. So that's why I'm kind of doing these live streams, just having a little fun, doing some homework, and then hanging out with you guys. So. All right, so let's kind of move back down a little bit. And so if we know that, here, let's actually, I hate when I do that. I keep on doing it. I don't hold it down long enough. So anyways, here's pi over 4, right? So if we want to go negative pi over 4, that basically just means we're going to do the exact same angle, but it's going to be down this way, pi over 4. Jeez. So that's going to be your negative pi over 4. And then again, if you look at this, if we kind of had this point, if we're reflecting this down to the 4th quadrant, it's really important as you kind of work these chapters to know what the sign changes are in the different quadrants, or what each coordinate has their sign changes. So when I reflect this down to the 4th quadrant, I could look at this understanding that I did here, or you could also understand in the 4th quadrant, the x and the y coordinates are both going to be negative. So therefore, my coordinate point is negative square root of 2 over 2, comma, negative square root of 2 over 2. Here, let me zoom in for you. And that's a horrible thing, but then if you're looking into the tangent, well, I'm not even going to do the work. There we go. That looks much better. I think that's a little bit easier. I'll erase that in there, but a little bit easier for you guys to read. So it's going to be negative square root of 2 over 2, comma, negative square root of 2 over 2, and therefore that's just going to equal a positive 1. So therefore, the tangent of negative pi over 4 is just going to equal positive 1. All right. All right, so let me go and take a break here before I get into the inverse trigonometry and kind of see where you guys scroll up, see where some of you guys are from, and kind of that. So if you haven't, or if you're just kind of joining us, I'd love to kind of hear where you're from, as well as what kind of math class you're taking, as I know some of you guys have kind of caught in since I've gotten started. So, well, thank you, Aubrey. I'm really happy to be able to help you with your math. Just keep on working hard, all right? Working hard, doing practice, and everything will be it'll start to show. Your efforts will come through. Sharon says, Brian, are you going to do a video by doing everything step by step from the beginning and going to the end of one day? Yes, my goal is getting into next year is to start doing some videos where I am taking you guys as the viewer, basically taking you as your teacher, hey, I'm going to teach you everything from the basic, and then take you kind of through everything just like you were taking, my class. Because I think one of the harder things that I get with my online videos is, people watch a video and it might be the first time I teach it. And they're like, oh, great, that's awesome. And then people are like, wow, you spent so much time explaining that. I just, you just need to do this and this. And I'm like, well, it was an introductory video. And then there's other videos where I'm just doing a quick little show you how to do it. It's more like a review video. And students are like, oh, that's perfect, just what I needed. And then other students are like, oh, well, I need you actually to explain what you're doing and not just, go through it so quickly. So, and there's really kind of no way to tell on my videos which video you're getting. So that's what I wanted to design these, is to kind of work from the very basic, for a student to take them from the very basic, but then also to work into some more advanced kind of videos. Hey, Darnell. Oh, yes, my bad. His fault. Thank you very much. Snow day, no snow days down in Jacksonville, Florida. All right. Okay, you guys, make sure you guys are nice here. Hey, Sasha, where are you from in Florida? I am in Darnell, from St. Lucia. All right. Hey, welcome, Elvis. Good to have you in here, man. You don't need to be taking a class. I'm obviously going over some stuff that is, can be covered in many other classes that you'll see. So glad to see that you're joining us here. And I don't know how to pronounce your name, but here are 3 more units. We have the state test. Yeah, I know this state test stuff is going to be going on. A lot of stuff be a lot of push, and I have a problem with a lot of the state tests that's going on with. A lot of the things that they want to push in with you guys is, this testing and all that kind of stuff. So unfortunately, there's not a lot we can get away from that right now, but, there's just some things is, do the work that you need, the practice, and then, just kind of do the best you can do. And that's really all us teachers and yourself can do. All right, so I'm going to go ahead and wrap up the rest of this. This is the homework for my students, so therefore they kind of know what's going to be going on as we move on into next chapter or move on to our next lesson and then our test. All right, so next one, let's go back to black. So the next question that we worked on is question number 9, and on question number 9 we had no, that was wrong. Question number 9 we had sine inverse of square root of 3 over 2. Now, where this problem came from is basically this problem came from having the sine of an angle equals the square root of 3 over 2. So when you see something sine inverse, or if you see it as arc sine, basically what they're asking is, when you take the sine of what angle gives you the square root of 3 over 2? What angle gives you the square root of 3 over 2? So I guess I'll be, I don't want to create another unit circle here, but I guess I'll just do it as we need them because I at least have my first quadrant, my unit circle memorized, so at least I'll remember that. So this angle, which is pi over 3, and again, I'll just kind of go through these as we need them. This coordinate 3 of pi over 3 has the coordinates 1/2, comma, square root of 3 over 2. And you can verify that if you obviously go ahead and scroll up. You guys can see that there's pi over 3, there's the coordinates, okay? No, don't do that. Where's my work? Uh-oh. I guess I lost everything. Oh, there it is. I guess I didn't scroll down as far as I wanted to. All right, so therefore, the angle, where it gives you sine square root of 3 over 2, is going to be equal to pi over 3. Now, I know I haven't talked about the restrictions on the domain, and until we need to talk about them, I will bring that up. And that because that's kind of a section all on its own. Guys, geez, oh man, come on. This is like teaching back at school. All right. Hopefully everybody can just enjoy a nice little lesson. I guess it's probably a good reason why I'm not displaying the chat on this video. Otherwise, it might not be able to be displayed. Okay. So that was actually not question number 9. That was question number 1. Oops. All right. So let's go ahead and work on question number 2. Now, here's where these restrictions kind of come up. So the next one is sine inverse of -1/2. Okay. Now, when we're looking into sine inverse of -1/2, the issue kind of comes up here is we're going to have, I hate this button. Doesn't, okay. When we're looking at this, so when we want to look at where is the sine of, -1/2, or, what angle does that create? We look at, there's actually 2 options. And the issue with the inverse trigonometry is when we're going to be evaluating these, you're only going to get one option. So when we actually do this, we see by the unit circle, there's actually going to be 2 angles that give us -1/2. And those 2 angles are going to be, so I'll do this, this, and this. So this angle, pi over 6, gives us the coordinate point of square root of 3 over 2, comma, 1/2. Now, if I was to take this point and reflect it across the x-axis, pi over 6, you can see that there, my y-coordinate is only going to be negative. So that would be square root of 3 over 2, comma, -1/2. Therefore, the sine, which is, represent the y-coordinate, is negative. Well, this point is going to be the same thing because all I'm doing, if I'm taking this point, I'm reflecting over the y-axis and the x-axis. This coordinate point is negative square root of 3 over 2, comma, negative 1/2. So I have two answers where sine is both equal to negative 1/2. And I got to be able to figure out, which angle is it. So what we got to do is we got to look at the restrictions on the domain. And I'm not going to get into this, or at least going to explain, because obviously it's in my notes and videos that I talked about. But remember, the restrictions on the domain, the way the easiest thing that I like to remember it is the restrictions on sine have to be in the first and the fourth quadrant. So our angles have to be in those two quadrants. That's at least how we restrict the domain for us to be able to find the inverse of sine. So obviously this angle is not going to be in there. And if we look at this angle, the terminal side lies in the fourth quadrant. Hold on a second. She's still up? She's barking? Oh, great. All right, so sorry about that. So as we work into this, you can see that this angle needs to, if I want to graph this angle, which is, pi over 6 away from 2 pi, so this angle is 11 pi over 6. It fits in the form that it's in this quadrant, right? But the problem is you had to go outside the quadrant. You had to cover, angles 2 and 3. So what we need is we just need an angle that is just in this, fourth quadrant. So that angle is going to be negative pi over 6. Okay, so anyways, let me kind of go over the restrictions of sine and cosine. So the restrictions of sine and cosine, sine of x and cosine of x. I'm sorry, sine of x and tangent of x. Those have a restriction of the first and the fourth quadrant, whereas cosine of x, I'll kind of put that up here. Cosine of x, when we're doing the inverse cosine, that is going to be in the first and the second quadrant. So I'll kind of talk about that as, obviously we get into some cosine problems. So, oh God, are you guys all doing okay? Do I? Jeez, I don't even know what to say. This is okay. All right. Well, I'm just going to continue teaching, just kind of like pretending I'm in my class right now, and I'll just kind of ignore this thing, but I hope you guys can settle it out. And obviously, if you don't want to be here in the live stream, you do not have to be in the live stream. So, I'm happy to go through and teach, but obviously if you don't need to be here, it's kind of like, that's the cool thing I like about this is it's not like in the classroom, right? If you don't want to be learning, then you're not learning. Like, just, go ahead and leave, watch other things on YouTube. Like, that's the cool thing. For those of you that want to stay and, learn some things, I'm happy to be here and teach. I'm kind of going a little bit, I'm kind of running behind though, so I am going to try to pick some things up to finish this homework. The next thing is number 7. I have tangent inverse of -1. So when I look back up to this unit circle, I want to see, well, when and where is tangent equal to -1? Well, if you remember at this point, we had square root of 2 over 2, comma, square root of 2 over 2. So if we put the y over the x, which is the tangent, that's going to equal 1. But again, we need the negative form. So tangent is only negative in the second and the fourth quadrant. And then based on my restrictions, I need to find the angle that's in the fourth quadrant. And then again, I can't go outside like this. So therefore, if positive pi over 4 gives me positive 1, that means negative pi over 4 is going to give me -1. So that's going to be negative pi over 4. Let's go work on question number 8, which is cosine inverse. Cosine inverse of negative square root of 3 over 2. All right, so in this one, again, we're looking into, when is the cosine, when is the x-coordinate equal to negative square root of 3 over 2? So as we look over this, we see that, the x-coordinate looking on this unit circle is going to be square root of 3 over 2, which gives us the angle pi over 6. However, we're looking for when it's going to be negative. So cosine is going to be negative in the second and the fourth quadrant. So let's go ahead and use green because we're going to make this kind of messy. So if I'm looking for the restriction, if I'm looking for what this angle is in the second quadrant, if I reflect this over, this angle, this pi over 6 in this is still going to be pi over 6. Like that doesn't change. That's like your reference angle. This coordinate point is the exact same point over here. It's just reflected over. So therefore, that's going to be, a negative square root of 3 over 2, comma, 1/2. Now the only difference is we need to figure out what exactly is this angle. And again, we got to go from the angle from standard form, which is from the positive form of the x-axis over to there. So if we remember that, half of a circle is pi, in terms of 6, that would be 6 pi over 6. So if we're 1 pi short, that means we're going to be at 5 pi over 6. And then last but not least is we got to make sure that 5 pi over 6 falls within my restrictions of cosine, which, yes, 5 pi over 6 is right there. It lies in the second quadrant. The other angle is the one down here, which would be 7 pi over 6, but that's going to be in the third quadrant. That doesn't fall within my domain restrictions, so that one doesn't work. So therefore, that angle is going to be 5 pi over 6. I have a bald head, but that's okay. That's all right. All right, let's get on to stop that. Let's get on to number 10. Number 10, I do not like these problems. And the reason why I don't like number 10, but I'm going to kind of move through it rather quickly, is tangent of negative square root of 3. Because what you need to do is you need to understand where's square root of 3. And the hardest thing about these is when you guys are doing these problems, you guys can see that, sine and cosine are rather easy to find. The sine is the y coordinate, cosine is the x coordinate, and tangent is going to be y over x. So we got to figure out which one of these, when I took the y coordinate over the x coordinate, is going to give me tangent. Well, there's only 3 possibilities. You have this point, and this point. And this point, since these coordinates are the exact same, that's going to give you 1. So I'm just going to pick this coordinate because I know that's the answer because I'm trying to save some time. So the y coordinate is square root of 3 over 2 divided by 1/2. And you could multiply by the reciprocal if you want to, or otherwise, later on you'll just learn that other simplified ways to simplify this out. And you can see we get square root of 3. However, the problem is saying that we're asking for what angle is, when we take the tangent of what angle gives us negative square root of 3. So again, if we're looking for the negative, tangent is only negative in the second and the fourth quadrant. Obviously, by the constraints of tangent, we need in the fourth quadrant. So therefore, if that angle is positive pi over 3, we need to find negative pi over 3. So the angle for that one is going to be negative pi over 3. All right, I only got 4 more questions, so let's move on here. And then maybe for those of you that still are okay with the the issues of the live stream chat, we can kind of maybe talk it out and maybe have a session with there. So last one, or second last one, is cosine inverse of 0. All right, so again, let's look at the unit circle. What angle then, when we take the cosine of what angle gives us 0? Now, I didn't put these down here. I should probably do that. So remember, this coordinate point here is 1, 0. And this coordinate point here is 0, 1. All right, so again, we're looking for the cosine inverse of 0. So, what angle gives us the cosine of 0? And you can see here, remember, cosine represents the x-coordinate. So that's going to be that point right there. So what angle gives us that? Well, up here, I showed it to you. That's going to be pi halves. You can see right there is pi halves. So that answer is pi halves. Oops. And again, let's make sure. Does pi halves fall within the domain restriction of cosine? Yes, it does. So that is good. So that answer is just going to be pi halves. Question number 12. Uh-oh, I got to finish this before my page runs out. So that's going to be sine inverse of 1. So what we're asking is, again, the sine of what angle gives me 1. And that's basically what we're looking at there. So again, I want to go back up to that circle and kind of say, all right, so when is the y coordinate 1? Well, if you notice, the x coordinate was 0 in the previous problem, and look at the y coordinate's 1 there. Excuse me. So we can see that that's actually going to be the exact same answer, pi halves. The angle pi halves gives us the cosine of 0 and the sine of 1. Yes, thank you. Everybody just needs to settle down. We're almost done with our math homework, ladies and gentlemen, and then we'll be moving on. All right, let's go ahead and finish here. Last two questions is composition. Now, when we're doing composition, the main important thing that I want to work on with with my students is just take things one step at a time and just kind of work from the inside out. So I like the composition problems because they involve both evaluating trigonometric functions and inverse trigonometric functions. So the first thing we want to do is evaluate on the inside. So the cosine of pi over 4, which is going back up to our unit circle, cosine of pi over 4 is our x-coordinate, which is square root of 2 over 2. So therefore, I'm going to replace the cosine of pi over 4 with the square root of 2 over 2. Let's actually do that. So therefore, I'll have the sine inverse of square root of 2 over 2. All right. Then now I want to do is, what is the sine inverse of square root of 2 over 2? Like, what sine of what angle gives me the square root of 2 over 2? Well, obviously, if the restriction has to be in the first or the fourth quadrant, we can see that that angle is going to be pi over 4. So the answer is pi over 4. Now, you got to be careful because not always is the restriction, just because you're doing the cosine and the inverse, is always going to undo each other and just to give you that angle, because it all depends on when the restrictions take place. And I'm not sure if, actually, I think I picked some problems that weren't good, but we did some of these in class for my students, where they weren't the same, but I'm not sure if I chose them the exact same on the homework. So either way, let's kind of get into this last problem, question number 30. And that's going to be arc cosine. Now, a lot of times using the sine to the -1, that inverse notation can be confusing, especially when we're dealing with derivatives and so on and so forth. So a lot of times we use arc cosine as an alternative notation. So that's where that kind of comes in. Tan of pi over 4, but it means the exact same thing. It just means cosine inverse. So why did I choose ones of the same angles? I chose some bad problems here. I'm going to have to redo this homework for later years. All right, so in this case, we're looking for the tangent of pi over 4, which is, again, square root of 2 over 2. No, I'm sorry. The tangent of pi over 4 is going to be the y-coordinate over the x-coordinate. And if you guys look at here, the y-coordinate over the x-coordinate, square root of 2 over 2, comma square root of 2 over 2, that equals 1, right? Okay. So the tangent of pi over 4 is equal to 1. Boom. So therefore, we're trying to find what is the arc cosine of 1. So we're trying to find the cosine of what angle gives me 1. And then so we can go over there, and we can see that here is 1. That's the only coordinate on the unit circle where the x-coordinate is going to be 1. So what is this angle? And it's basically the angle of us not even moving at all. And so that angle is actually 0. So there you go, ladies and gentlemen. That is how you work through your homework. Ta-da. All right, so now let's kind of take a look at you guys to make sure this is a kid-friendly, appropriate kind of screen. See if anything can ask. So I'm kind of done going through my homework. When I kind of do the replay, I will kind of cut this section out because it's just going to be kind of me talking and so on and so forth. But is there any other questions? Oh, it's 9:15, it's 9:14. So wow, okay. All right, well, if anybody has any questions that I can maybe help you with, I'll be more than happy to do that. But I do want you guys to know a couple things. Obviously, I do plan on doing this a lot more. So if you haven't already subscribed, I'd love to have you subscribe. And also, you can click the bell notification that will at least alert you, because at this point, I don't really have a schedule. I would love to say I'm going to be doing this, every Monday, Wednesday at 8 o'clock or 9 o'clock or whatever else. But probably till the rest of this school year, it's going to be kind of haphazard. It's going to be, I might do one at 7, I might do one at 3, might do it at 9 o'clock. It's just really going to depend on my schedule and what we're doing. So if you guys want to, get alerted for the next time I do a stream, you can click the bell notification, and that will get you guys alerted. But it looks like you guys are pretty understanding, because it looks like you guys are just communicating with yourself and don't really have any question. But did the lesson go okay? Did anybody feel good? Was this something new, or I need help with linear equations. I'll be bringing up some stuff. I don't have a lesson prepared right now, but I will get some things up for some more Algebra 1, Algebra 2, geometry topics. Definitely in the works. So I appreciate for those of you that were worked through this, and this may have helped. And I'm sorry for those of you that might have been a little distracted on the chat. I don't want you guys to obviously come to a live experience or my live streams with a bad experience. But yes, it is Tuesday. Well, I was just saying like Monday, Tuesday, Wednesday. I don't know when I'm going to be doing this lesson. So, but anyways, guys, I appreciate you guys hanging out with me. I am going to get ready for tomorrow and get everything set up. But again, get that notification if you haven't already, because I do want to go live at least a couple more times a week. I'm not sure if I'm going to have one more in me this week, but if I do, if you got the notification, you'll be notified. So either way, guys, I look forward to having you on the next one, and have a good night. Take care. Bye. Oh, I should probably have that.